If you've spent any time reading about AI agents, you've probably hit a wall of jargon. Agentic loops, tool calling, orchestration layers, and somewhere in there, agent harnesses. And here's the thing, nobody really explains what a harness is. They either assume you know, or they bury it in a 15-minute framework tutorial that teaches you how to use LangChain without ever explaining what's actually happening underneath. So in this video, I want to fix that. We're going to talk about what an agent harness actually is, why it exists, and by the end, I'll show you one I built myself. Let's start with the raw LLM. At its core, a language model is a text-in, text-out machine. You give it a prompt, it gives you a response. That's it. It has no memory of your last message beyond what you explicitly gave it. It can't browse the internet, it can't run code, it can't call an API. By itself, it's extraordinarily smart, but completely passive. So people started asking, what if you could give an LLM tools? Let it look things up, run calculations, write and execute code. Suddenly, you've gone from a very smart text box to something that can actually do things in the world. But here's the problem nobody talks about. The LLM doesn't know how to manage those tools on its own. Someone has to decide when to call a tool, collect the result, feed it back to the model, and decide what happens next. That someone is the harness. Let me make this concrete with something you've probably used: Cursor. Here's a question worth sitting with for a second. Cursor uses the exact same models you can talk to in ChatGPT or Claude, same underlying intelligence. So why does Cursor feel so much more capable? Why can it edit your files, run your tests, read your whole code base, and fix an error on its own, when the model in the chat window can only give you a block of code to copy and paste? It's not a smarter model, it's the harness. Think about what you do when you use a raw LLM in a chat window. You paste in your code. It suggests a fix. You copy that fix back into your editor. You run it. It breaks. You copy the error message back into the chat. It tries again. You're doing all of the work of moving information back and forth. You, the human, are the harness. Cursor just automates that entire loop. When the model wants to edit a file, Cursor edits it. When it wants to run your tests, Cursor runs them and feeds the output back. When something breaks, the error goes straight back to the model without you lifting a finger. The model proposes, Cursor executes, the result comes back, and it goes again until the job is done. That automated loop is the harness. And once you see it, you can break it down into 3 jobs it's always doing. First, it manages context, deciding what the model sees in each turn. Your code, the last error, the conversation so far, etc. Second, it executes tools. When the model says edit this file or run this test, it's not actually doing that. It's outputting a request. The harness is what actually runs it. Third, it runs the loop, deciding whether the model is done or whether it needs to go around again. This is why it's called a harness. The model is the engine, powerful but directionless on its own. The harness is what straps it to a goal and keeps it pulling in the right direction. I want to show you a real harness, one I built from scratch for a project called Ergo. Ergo is a macOS app I built that's essentially a Lean4 IDE with a Claude agent built in. Lean4 is a formal proof assistant. It's used to write and verify mathematical proofs. The idea was, could an AI agent actually write and iterate on proofs using Lean's verifier as a feedback mechanism? And the key insight was that the harness is what makes this work. Here's what it does. When you ask Ergo to prove something, the agent doesn't just generate a proof and call it done. The harness takes that proof attempt, runs it through the Lean compiler, and gets back to the error state or proof state, and feeds that back into the model's next prompt. The model sees exactly where it went wrong and tries again. That loop, LLM proposes, Lean verifies, harness feeds the result back, is the harness doing its job. Without it, you've just got an LLM guessing at math. With it, you've got something that can actually iterate toward a correct proof. And this is the thing that makes agent harnesses genuinely interesting. The quality of the harness determines what the agent is capable of. A sloppy harness loses context, mishandles errors, and breaks the loop. A tight harness multiplies what the agent can do. The LLM gets the credit, yes, but the harness is doing a lot of the work. So, to recap, an agent harness is the scaffolding that manages the loop between an LLM and the world outside it. It handles context, executes tools, and decides when the agent is done. Frameworks like LangChain are pre-built versions of this. But under the hood, they're all doing the same thing. Once you understand that, a few things become clearer. Why agents sometimes go in circles, why context window management matters so much, and why building a tight feedback loop, like Lean as a verifier, can make an agent dramatically more capable. I'm planning a whole series on how agents actually work under the hood, grounded in things that I've actually built myself. So thanks for watching, and I will see you in the next one.